use a negative exponent when you have a tiny number, positive when you have a big number. If you get confused about that, try typing this number into your calculator. And the way you'll do that is by just typing 1.02, hitting the exponent button, and on most calculators, it's shown as EE. So you just type in 1.02 times 10, or the EE, to the minus 3, and it shows you this exact number. I'm sure you won't be able to see on my head that I wrote right here. Okay, so let's do this same principle for this number. This number is this number in scientific notation. Here for the big number. Okay, first of all, we have to identify the first non-zero number. That's this one right here. So what we're going to do is we're going to move our decimal point so that this is the only number out to the left of the decimal point. 1, 2, 3, 4. We had to move it over 4 times. Now we're going to rewrite the number with the decimal point right here. 1.0012. Now, remember we had to move it over 4 times? We have to account for that. Times 10 to the 4. Now, because we had to move the decimal point to the left, where we're making it where we have a very large number, it's going to be a positive exponent. And this is how you write this big number in scientific notation. Let's do a few examples of this as well. That's a very small number. And we'll do a very big number. 3 million. Okay, I want you to pause it, practice writing all of these numbers in scientific notation, and then resume when you have answers for all of the problems. If you don't write down your own answers for all of the problems, you might not know where you're going wrong. Okay. So here we're going to have to move the decimal point to the right 1, 2, 3 times. So that number in scientific notation is 1.23 times 10 to the minus 3. Here we're going to have to move it 1, 2, 3, 4, 5, 6. Times 10 to the minus 6. Now in this case, there's no decimal point that's explicitly written. But remember that there's always a decimal point at the end of a number if there is not one explicitly stated. So here's where my decimal point is. I have to move it to the left 1, 2, 3 times. So here I'll have 2.506 times 10 to the positive 3. And now just a matter of convention, you don't write the plus in front of the 3 because if it's positive, that the plus sign is implied by just the number 3. Here's another case where you have a decimal point right at the end. 1, 2, 3, 4. So we have 3.0001 times 10 to the 4. And now for our super tiny number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1.0 times 10 to the minus 10. This is the length of a bond between 2 atoms. Here we have 3 million. We're going to move our decimal point 6 times. 1, 2, 3, 4, 5, 6, 3. And now, this is where the trick comes in. You have to write down all of the numbers in your scientific notation that are significant in your number. There's a decimal point here. So all 6 those zeros are significant. So we are, excuse me, 7. We have to write all 7 of those zeros. 3.1, 2, 3, 4, 5, 6, 7. 3.7 zeros times 10 to the 6. That's a lot of significant figures. That's more than you'll ever see in this class. And that's how you put things into scientific notation. Again, just like with the significant figures, if you're having questions, go back, review the lecture, take a look at the Smartboard notes and see if you can't figure out what your problem is. Sometimes repetition is just the answer to solving the riddles of chemistry. Okay. Now we can talk about using significant figures in calculations. Okay, there are 2 different rules. One is easy, one is complicated. We'll do the one that's easy first. Okay, so anytime you're going to multiply or divide 2 numbers, 2 or more numbers, this is the rule that you use. Okay, so the rule states that the number of sig figs in your answer is equal to the smallest number of sig figs in your problem. Give you a moment to digest that. The number of sig figs in the answer, the number that you'll report to me that you'll circle as your final answer, is equal to the smallest number of sig figs in your problem. Okay, so let's just do some easy basic math. 100 times 2. You don't need a calculator for that. Your answer is 200. Okay, how do you determine how many significant figures should you report in your answer? Well, based on the rule, it tells me that the number I should have here is equal to the smallest number in my problem. Okay, so you have to identify how many each of your numbers has in your problem. Here you have 4 sig figs. Here you have only 2. Which number is bigger? Or I should say, which number is smaller? 4 or 2? 2. So this number needs to have 2 significant figures. Okay, this is tricky. We've got the number 200. If I put a decimal point here, that would give me 3 significant figures. That's not right. If I wrote this number, 20, that would be the right number of significant figures, but 100 times 2 isn't 20, it's 200. So we can't write that, that's not right. So what do we do? Well, you have 2 options. The first option is to put it in scientific notation. So here's your decimal point. You're moving it over to the left twice, so that would equal 2.0 times 10 to the 2. The reason I only put 1 0 here instead of the 2 is because I can only have 2 significant figures. So I have 2.0 times 10 to the 2. Now, the second way to write this number with the correct number of significant figures is to put a bar over the number, the last number that's significant. Like this. That bar means that you have only 2 significant figures.